I have mentioned earlier. It uses cryptographic hash functions to generate indexes where you assign your various key value pairs. And it also has its applications in database management structures, search engines, and caching systems, which make the use of hash tables to quickly locate and retrieve relevant information from a large amount of data sets. And what makes hash functions so efficient in searching and retrieval is the fact that they can store key value pairs in them dynamically, which means in real time. So even if the size of your data set is increasing, they can still implement this hash table operations in an efficient manner. So for hash tables, we shall be studying these following operations, that is the set item, the get item, and keys. And as usual, we shall be initializing our constructor as well. And we shall be implementing hash tables using lists. And once you study about hash tables, you'll learn something interesting. So let's start with an introduction. For example, in a hash table, you want to store a key value pair. Let's take an example of keys being nails and value being 1000. So what you'll do is you'll take your hash function and you'll pass your key value pair through this hash function and use. Sorry? What are you saying? Can you repeat that? Does somebody want to say something? Kartikeya, Samyadeep?
No, I didn't say
Somebody's
anything. My mic was off as well. My mic is off as well.
Okay, let's continue. So you take your key value pair and you pass it through your hash function. And using this key, this nails, your hash function will be generating a value which will be called your hash. And this hash will be nothing but the index where your key value pair shall be getting assigned its location. Now, there are two qualities of a hash function which should be taken into account, which is that a hash function is one way, which means you can pass the value nails to it and generate this key, this hash value 2. But if you pass 2 into your hash function, you can't generate nails through it. It doesn't work like that. So this is what we mean when we say that a hash function is one way. You can't go in a reverse direction in a hash function. And a hash function is also deterministic, which means that every single time you pass this key nails into it, it will generate the value 2 only. It would never generate a different value for your nails key. Okay. So these are our functions that we'll be learning. The set item, which sets new key value pairs into our hash table. So we'll be generating the index for our key value pair, and then we'll be assigning our key value pair onto our hash table. Then we also have the get item method, which shall be retrieving a particular just a second. The get item method, which will be retrieving the value based on the key that you passed into it. So for example, you passed I'll show it to you again. So our get item function will be taking in the parameter of, for example, bolts into it. And from this key, it will generate the hash and find out what is the value assigned to that specific key according to that. You learn it soon. As you can see, this is the index of your bolts key, and based on that, it will be retrieving the value of your key value pair. This was our introduction to hash tables. Now we'll be studying about one more concept of hash tables, which is collisions. So hash tables are not resistant to collisions. Many times, whenever you're passing multiple values into your hash function, it might happen that two different keys will generate the same index location for your hash table. So at that time, for example, here you can see nails and nuts have the same index. So there are various ways to combat this collision problem. One way is, just a minute. Yeah. One way is through either linear probing or through separate chaining. One is open addressing or separate chaining. Under open addressing, you have linear probing and quadratic probing, and there is another method that is separate chaining. So in separate chaining, you simply add all of the elements into the same index um, by forming a nested list. And in open addressing, you have either linear probing. In linear probing, you simply find out the next empty list area. If it was quadratic probing, you would have taken the square of the value. We won't be studying about this here, and neither are we going to study about linear probing. We'll be simply studying about separate chaining for our application of hash tables. So we'll be implementing this through the concept of nested lists, and I will give more clarity on it using um, real runtime code. I'll open it in PyCharm and show you how it is actually implemented. Now let us initialize our hash table constructor. So one thing to keep in mind whenever we are defining our hash table is the size of our hash table. Always make a hash table with size equal to a number that is a prime number, because in hash function we shall be taking the modulus of a number along with the prime number, which is the size of your list. And the reason why we take a prime number is so that you can generate many random values. This is to prevent collisions, but still it's not impossible to prevent collisions. So we'll be defining our hash table class here, and this is our init function, which takes a self parameter and a size parameter. And in our case, we are taking the size of our hash table to be equal to 7 by default. And if we don't pass any value into our hash table, whenever we are defining our own object, then by default, it will be taking in size equal to 7 as its size parameter. Now we are going to define our hash table. So as I said, we shall be implementing our hash table using list. So as you can see, we have defined our hash table variable, which is called self data type, and it's equal to none, and it's multiplied by the size. So you will be getting um, seven different locations to assign your various key value pairs in it. Now we shall also be initializing our hash function. So let's take a look at how it works. So as I said, our hash function will be taking the key of our key value pair as a parameter. For example, you have not nails as the key and value to be equal to 1000. So in our hash function, we'll be passing in nails as its key parameter. And then it will be carrying out the hash operation on it, and it will be returning your hash value. Let's see how it works. So we'll initialize a number, my hash, to be equal to 0. Now we will start iterating through the letters of our key. So we'll define a for loop for that. And now we'll be updating the value of our my hash variable. So for that, just pay careful attention to this. We'll be updating the value of my hash by writing this line of code, which is my hash plus odd of letter into 23 and modulo with the length of our hash table. Can somebody tell me what does this odd letter mean? What does it return? You have studied it in Python. Can somebody unmute or send their answer in chat box? Yes, ordinal value ASCII. What is done by saying when do we define methods as method name? I actually don't know about that. I never had this doubt. Yeah, everybody is right. ASCII value of the letter shall be returned. I will give the answer to this question soon, Tanha. Please wait. Yeah, so this odd letter will be returning the ASCII value of our letter. So after running this function on our letter, at the end, we shall be returning my hash. So this is essentially an affine cipher. Just a minute. Somebody has their mic turned on. Hey, Rajesh, you can unmute mute people, right? So if you see somebody has their mic on, can you just mute them if it's possible?
Yeah, yes, I'm doing that.
Okay, okay. So this whatever code line we're seeing here is actually an affine cipher, and all the freshers might not know about this, but in their next semester they shall be studying about this in district mathematical structure. There again, this hash function concept shall be repeated, and um, you'll understand this is actually a function where this odd letter shall be our x and b 23 will be our b. Let's not get deeper into that. But you guys will be studying about this in your next semester as well. So this is essentially our affine cipher, which is a function which returns a code basically. You can call it a code and you can encrypt it and decrypt it, which is essentially what we do in hashing. So at the end, we shall be returning my hash. Now let us run this code with our custom input. As you can see here, as I said, if you don't pass in any parameter to your class, then by default it shall be taking in 7 as its size. So this is our initial hash table with all of the indexes having a list to it, and all the list values are basically none. After this, we'll be carrying out modifications on our hash tables. Any doubts until here?
No doubts.
Okay, let's continue. Now we shall be studying about the set item function. So in our set item function, you'll be adding in your key value pair, and it will be basically generating a index for your key value pair, and then you shall be assigning your key value pair into that specific location. So as you can see, our set item takes key and value as its parameters. So your entire whatever new value you want to add into your hash table, which will be passed into your set item function. So in our function, firstly, we'll be declaring an index variable because whatever hash value we generate from our hash function will be considered as the index of our key value pair. This must be clear by now, right? So index will be our variable which I'll be storing the value of the hash value that you have generated from your hash function for your key. As you can see here, now if now we shall be initializing um, this specific location with an empty list because previously it was none. Now this operation shall be carried out only if the value at that specific index is equal to none. If you like remember, like just right now, when we initialized our hash table, all of the values at the index were equal to none. So in order to make changes in our hash table, we'll be initializing the value at that specific location to be equal to an empty list instead of none. Now we'll be simply appending the key value list into our hash table using this function call. It might be like a long code to understand, but it's pretty simple actually. As you can see, at this specific location, this specific index, you'll be appending your key value. Since we have already defined our hash function, the set item function is very easy to implement. As you can see, based on the based on the hash values that are generated, we are assigning our key value pairs to those specific indexes. Let's run this code so that you can understand how exactly it works. So you can see our function is declared here, and we are going to set these key value pairs into our hash table. So after we run this, you can see this is what has been generated. So you can see bolts and washers. This key value pair is in the same index. So we experienced collision here, and we combated it using separate chaining. So in separate chaining, we start nesting our key value pairs. So these key value pairs are also essentially a list. So we'll be using the concept of nested list to carry out our separate chaining, which is our collision resolution technique. And as you can see, our lumber and 70 key value pair is at index 6. It depends on the kind of key value that has been generated. I shall explain this concept in our PyCharm console as well to explain this more properly so that you'll understand exactly what is happening here. Were there any doubts until here in the set item function? Take that as a no. Now we'll study about the get item function. So our get item function essentially takes in the key as its parameter, and it generates the as I have mentioned earlier, it generates the hash value, which is the index of your specific key, and it will be returning the value associated with your key. So as you can see, we passed in, for example, we first passed in washers as our key. Then it found out the index where it is located in a hash table, and then it found out the value that is associated with that key with washers. And then we did the same with lumber, and then we were returned with none because we don't have anything like that in our hash table. We don't have that specific key value pair. So again, our get item function will also be declaring this index variable, which shall be taking in the hash value that has been generated from our hash function. And now again, if the list at the specific index is not equal to none, then we shall be running a for loop, which shall be iterating through the nested list. Now, this might feel a little confusing, but I'll explain it again. See, yeah, we first found out the index of our key using our hash function, and then we iterated through our list to reach that specific index, and then we are going to access this specific nested list, as you can see here. So we have our for loop for that. So can anybody turn on their mic and tell me exactly how are we going to iterate through this nested list? I'll wait for 2 minutes. You can either turn on your mic or send answer in the chat box. Okay, let's make it easier. I'll give options to you, option one and option two. Option one says that it shall be iterating through each and every single element of our nested list. For example, bolts will be when I equal to 0. 2 will be when 1400 when I equal to 1. When I equal to 2, we'll be returning washers. When I equal to 3, we'll be returning value 50. Or is it like when I equal to 0, we'll be just returning this specific key value pair, that is bolts and 1400, this entire list. And when I equal to 1, we'll be returning washers and 50, this key value pair. Is the answer option 1 or 2? Okay. Okay, Samedip says 2. Enumerate function. Why are you saying enumerate function? Or we can use the enumerate function. Okay. Any other answers? Is it option one or option two? Are we going through each and every single element, or are we just going through one nested list and then another nested list? What is essentially happening in our for loop? Any other answers? Okay, I guess no more answers. One, no, it's not one, it's option two. We'll be returning this entire key value pair when we are carrying out this for loop. As you can see, this for I in range length of this hash table. And after we have run this for loop, we shall be checking out the keys inside a nested lists. For that, again, we shall be checking out this every single list. So firstly, as I said, we'll be iterating through our entire hash table. We'll be finding out the nested list at the particular index. And then we'll be, for example, if I is equal to 0, when I equal to 0, we will be checking out this first list, this bolts 1400 key value pair. And again, we have passed in 0 here, 0 index here, which means that in already nested list of ours, we'll again be going through our first list. And in this list, we'll be going through the first element of the list, which means the key of our list. Any doubts until here? If there are any doubts, just turn on your mic and tell me. I will explain again. It is a little tricky to understand. We'll understand this more in depth. So we'll be comparing the value inside this whatever we have declared over here with the key value that we have passed in our get item function. And if that's not the case, then we'll be moving on to the next dictionary, and we'll be comparing the key value here to the key value that has been passed. And if it is equal, we'll be returning the value associated with our key. Otherwise, we shall not be returning anything. If there's anybody who didn't understand the concept, just raise the hand and I'll repeat this again. Otherwise, I shall be moving on to the next function. So as you can see, we first iterated through our list, then we stopped at the index, which has stored our particular key, and then we iterate through the lists that are located at that particular index, and then we compare the keys located in that particular list to the key that has been passed in our get item function. If it's not there in our first list, then we'll be going to the next list and we'll continue to compare it with the key. And if at the end you don't find anything, you'll be returning none. Just take a proper look at this function. You can try to implement it as well. If there are any doubts anywhere, just ask me. Let's run our custom input on this. So first of all, we set item bolts with 1400 value and washers with 50 value. Now we shall be carrying out our get item function on bolts, washers, and lumber. Can somebody tell me what will be the output for all these three get item function calls? Just send it in chat box. Uh, Return none. Is the return none the fall through case for the loop? Whenever we don't find any value from our list, whenever the key doesn't match with your the key that you have passed in your get item function, then you will be returning none because you didn't find anything, which means the key value pair doesn't exist in your hash table. So we'll simply return none. Is that clear then now? Okay, so I'm waiting for the answer to my question. What will be the output of our get item function for these three function calls? First one is bolts, second one is washers, and the last one is lumber. What will be the output? 1450 and none. Okay. Everybody else? Okay. Samyadeep. Okay, Yashaswini. Uh, okay. Utkarsh. Any more answers? Rest everybody. Okay. Everybody has given the correct answer. We'll be returning the value for bolts and washers, and for lumber, the lumber key value pair, nothing like that exists in our hash table, so it shall be returning none. Now we shall be studying about the keys function. As you can see here, our keys function wouldn't be taking in any parameter. Our keys function will simply return all the keys whichever we want to return. Just a minute. Yep. So it shall be essentially iterating through the list, and it shall be finding out if there are any indexes where there are any lists, which means any key value pairs, and it shall simply return all of the values inside our hash table. So to implement this function, we will be first declaring an all keys variable, which will be an empty list, and we'll be appending all of our keys into our all keys list. So we'll start iterating through our hash table, and then we'll be iterating through the nested lists of our hash table at that specific index. And this specific for loop shall only work if the specific index is not equal to none. Is everything clear until now? Any doubts?
Uh, can you just repeat this one more time? I wasn't able to hear for some time. Sorry.
Okay, okay. So we are defining our keys function, and our keys function will. Can you turn off your mic? Somebody. Okay. So our keys function wouldn't take in any parameter as its input. It will simply return all of the elements of our specific hash table. Not all elements, just the keys of our hash table. So it will do so by iterating through our list, and then it will keep on checking if the value for at that particular index is equal to none. And if it's equal to none, it will simply move on to the next index and so on until it finds out an index where there is a key value pair stored. And it shall be returning the keys at that specific index. Now, because we are implementing separate chaining, we have nested lists in our hash tables. And there could be some places where there are multiple key value pairs stored. So for that, we'll have to iterate through the all of the lists that are stored in that specific location. For that, we shall be implementing this for loop. And this for loop will be returning, just a minute, we'll go from starting, right? As I said, this for loop will only be executed if the value at that specific index is not none, which means there is a key value pair stored there. So if there is a key value stored in a specific index, it will loop through the key value pair list. For example, it will first go through the bolts and 1400 key value pair, and then it will be um, assigning the value of appending the value of bolts into the all keys list. And then it will move on to the next key value pair, and then it will be appending the value of washers into the all keys list. As you can see here from the code, self dot data map I means that we have reached a specific index. Self dot data map I j means that we are starting to go through the nested list. And this 0 means that we are returning the first element of our specific list, which means the key. And then at the end, we shall be returning this all keys list that we have declared. Now let's try to run our custom input where we have first set our item, we have used our set item method to add the specific key value pairs. And then we just call our keys function on our object, and then we'll be simply returning all of the keys located inside our hash table. So this is all for hash tables actually. Does anybody have any doubts until here? Okay, now
No.
I shall now I shall be um, taking our PyCharm console. I shall be using it to make this concept easier. I'll show how exactly this hash table is implemented. So I made a few changes in our hash function so that we can get an idea of what exactly happens here. So as you can see, we have our initial code, and I just said, like as we are running through our for loop, for each and every single iteration, we'll be returning the ordinate of that letter, and we'll be returning the hash value. As you can see, this is how we implemented the hash function on that specific letter. And then we'll be returning the my hash, which is the final value that we get after we add we after we keep on adding this hash value into our my hash variable. So after I run this, you'll see yeah, our custom input, I just took in some random letters into our hash function, and we run our hash function. As you can see, for example, for this character J, our ASCII value is 74. And after we carried out our hash function on our letter, it returned the value 1. So initially, my hash will be equal to 1. Now we did the same with our next letter, and the ordinal of our next letter is 70. Now, if we divide 70 by 7, obviously it won't be having any remainder. Okay, let me explain exactly what is happening here. We are taking modulo with the length of our hash table. So we initialize the size of our hash table to be equal to 7, and that's why we'll be taking our modulo with 7. Does anybody know what this modulo function does? Modulo operation? Listen, the
Dividing
order of
everything in the
input.
remainder.
Yes, correct. Remainder. Perfect. Yes, correct. The order of input will not affect the hash tables. Do you mean like the value of order of the letters assigned into our hash function? Am I? Are you trying to say that if I rearrange the letters of our key, are you saying that the if it has any impact? No, I don't think it would have any difference because see, for item 1, there will be a different hash value generated, and for item 2, there will be a different hash value generated. So it will be assigned to those specific locations in our hash table. And it doesn't matter what the order is. It won't make a difference because eventually it will still be assigned to our same index wherever whichever is the relevant position based on the hash value that has been returned by our hash function. In the beginning itself, I said it that a hash function is deterministic and it's one way. So if it's deterministic, it means that the value of the hash value that has been generated won't change, even if we um, keep on giving the same input all the time, it won't make any difference. You can understand your confusion, but there won't be any difference in the key value that is generated in our hash table. If you want, I can try to run this code. I will take item 1. I will show you what exactly would be happening here. Item 1. And then let's run it on item 2. Okay, so for item 1, we got the my hash value to be equal to 1. And for item 2, we got the my hash value to be equal to 3. As you can see, the hash value is different. And even if the hash value was same, we would have used our separate chaining method to form a nested list, and we would have stored them in the same location. I guess it's a little confusing. Oh, you understood. Okay. So as you can see here, for the letter I, this is the ordinate, this is the individual hash value for it. And so this is our my hash initially. And then for our next letter, this is the ordinate, this is the hash value. And since the hash value is 1, we add it to our my hash, so it becomes 1. And then again for our third letter, we'll be having individual hash value to be equal to 6. Wait a minute, something is wrong. Oh, yeah, when we carry out our entire operation, there would be changes. Yeah. So as you can see, first our value was 1, and then our next value was equal to 6. When we add 1 plus 6 and we carry out our entire modulo operation, the so we'll be carrying out modulo operation on number 7, because individual hash value here was 6 and our previous my hash value was 1. So when we add 6 to this one, we'll have 7. And when we carry out modulo on it, we'll be returning 0. So we came back to our initial value. Then we take our next letter, and then we carry out hash function on it. Then it returns value 1. Then for our next number, next letter, I mean, this is not a letter, so I don't think this would be a valid way to write out your key. I think so. But anyways, the hash value that was generated was equal to 0. And so at the end, our my hash was 1. Does anybody have any confusion here? Is it clear? Okay, now we shall be getting some more clarity on this nested list concept. So as I said, whenever we are using this separate chaining collision resolution technique, we'll simply start nesting our key value pairs into the same index. And if we want to understand how this nested list works, I'm pretty sure you've already learned about this, but let's just brush up more on this so that after you see this here, you'll understand what's actually going on in our code, in our ing. There we have written ing, and here we've written actual value. So this is our nested list. First list is a 1, 2, 3 list. Another is 4, 5, 6, and 7, 8, 9. And this is our entire nested list. So when we want to print out nested list 0 value, we'll be returning the entire list at the index 0 of our nested list. And then when we try to dig deeper into our nested list, for example, we say index 1, which means we'll start to look into this 4, 5, 6 list. And then we want to return the value at location 2, which would be equal to 6. Now we'll be doing again some nested list operation. We'll go to 0, 1, 2. We want to carry out operation on our list that is located at this particular index, which means the last index. And we want to return the element at index equal to 0. So in that case, in our 7, 8, 9 list, it would be 7. Is that understood?